What we're trying to do here is incredibly challenging. We're going to have an autonomous aircraft with passengers on board, but the aircraft is not just in the world behaving on its own, right? There's a human on the loop called our Multi-Vehicle Supervisor, and they're really there to ensure the safety of the mission, the continuity of the mission. So designing a safe, human-centered system means understanding our supervisors.
We study how operators interact with our systems and how that interaction impacts their workload. There are many different ways in how you can measure workload. One of them is what we call subjective scales. You let them tell you how they felt. The other kinds of measures are what we call objective measurements. Heart rate can indicate when a person is experiencing higher or lower workload. We also use eye tracking glasses just to understand how people use the interface. So we try to do all of this at the same time.
Once we complete the testing, then we have to do the hard work of actually analyzing the data. And then that directly feeds into the redesign of our UI. So we're both refining the UI and refining what the MVSor is. And behind it all, simulation.
It allows us to simulate very specific scenarios, very specific controlled scenarios, so we can tell how many aircraft, what exactly are they doing, what is the schedule of departures, simulate the demands our multi-vehicle supervisors face on the job.
What we do now is going to inform aviation for the next 100 years. It seems like a small step right now in terms of having autonomous flight, where one person is piloting many aircraft, but it could soon be the norm.
What we learn feeds directly back into our design, and that shapes the tools that help the MVSors do their job better, safer, and with confidence.